So the U value of the window in those locations was 3 or 3.2, that sort of order. Compared with if we were designing, for example, to German passive house standards today, we would go for 0.8, so huge difference. The walls we had at 0.25, again, if we were to passive house standards today, we would be going for 0.1 or thereby, but that's relatively easy to upgrade. The combined effect of double glazing on the outer skin of the buffer spaces and the inner glazing actually gave us U values of below 1.2. The average U value, taking into account both sets of glazing. So in fact, to get that down to 0.8 would be a relatively simple matter. The other weak link in the scheme of things was the way people, having got a relatively inefficient heating system by today's standards, there was the question of how they set thermostats. Now that would still be an issue today, regardless of how efficient the boiler was. What we found at East Hall was that people who set the thermostat to a comfort level in the living room and didn't really make much use of radiators in the other spaces were by far and away more efficient than the people who set their thermostat high on every radiator in the house. And actually the interesting thing is that if one compared the lowest consumer with the highest consumer, two things. The temperature in the living room didn't vary much at all. The temperature in the rest of the house would vary significantly, but not dramatically. The comfort levels from the lowest consumers were still reasonable. The other big difference was the rate of air change. So there was a large difference between the lowest consumer and the highest consumer. The lowest consumer was just below 25 kilowatt hours per metre squared per annum for space heating. The highest consumer was 215. Enormous difference, a differential factor of 8.7. So there we have it. The key things was the issue of how thermostats were set and how ventilation was regulated. The final weak link was the air collectors itself. So this was one of the buffer spaces with clothes drying, so we see we've got moisture out of the buffer space. This was the initial sketch working drawings showing the upgrading to insulation in the roof and both buffer spaces on each side. And this was the schematic for the air collector. The function of the air collector, having got the space heating down to a low level, was actually to tackle two things. One was to preheat the domestic hot water, and the second was to include the entrance stairwell into the circuit, and so that would be slightly pre-warmed. So the air collector took air from the top of the stairwell, heated it up on a sunny day, and that then went through an air to water heat exchanger, heating the water, and then a fan took if you like, the loose change from the thermal benefit down to the bottom of the stairwell, from whence it circulated up to the top again. The weak link was actually at the exchange. Initially, the system was tested out with reused radiators from a transit van, which was highly efficient. Unfortunately, it was found that that was in aluminium, and the risk was that it would start to react with copper piping, and so those were replaced with purpose-made units, which were much less efficient. However, the setup, the collector itself worked well, and with an efficient air-to-water heat exchanger, it was proved to be perfectly viable. So that takes us, we've pointed out all the weak link factors of the East Hall project as it was. Nevertheless, all sounds very negative, but at the time it brought whole house heating to a considerable level of comfort within the scope of all the tenants, even the ones that were heating to the highest level, ventilating to the highest level, and therefore spending most money, found it affordable. But how do we get that down to zero carbon, and what zero carbon are we aiming for? Well, the target was to see theoretically, if one could take a house today down to zero space heating carbon emissions, zero water heating carbon emissions, and also the other regulated uses such as lighting and pumps to circulate the water, and any fans such as this fan here to circulate air. So in other words, the Scottish regulated energy uses, can we get that down to zero carbon? Well, looking at the plan, the obvious things to tackle first of all are upgrading the wall to higher standards. That's relatively simple. All we need is more insulation on the outside. To get the windows to a higher standard, say a passive house standard, all we have to do is spend money and we can get a triple glazed window which will achieve an overall U value of 0.8. To get the buffer space combination down to 0.8 is less demanding. We can then address also upgrading the insulation in the party wall position here and other small parts here with internal insulation. That's the easy bit. The tricky bit is then addressing the heating and ventilation system in an energy efficient manner. And having got the U values down to that kind of level, opaque surfaces 0.1, windows 0.8, really we don't need much of a heating system. So instead of having, as shown in the original plans, radiators in all the rooms, the option that I'm looking at as viable would be to have a heat recovery unit located for all 3 flats up in the attic space, recovering heat from the wet areas, and linked to an air source heat pump. Now there are 2 possible locations for this. One would be in what was originally a fuel store. That means it's accessible still off the common stairwell. And if both the heat recovery unit and the air source heat pump were located there, one could then deliver warm air through the now redundant chimney. In other words, instead of taking air up through the chimney and out, air would be delivered through the roof space to the top of the chimney head and then down, delivering into bedrooms and living room. That then leaves the minor bedroom and the bathroom. The bathroom would probably have a towel rail and still a small radiator possibly in the smaller bedroom. The kitchen wouldn't need any heating at all because it's got plenty of incidental gains from the equipment. And so a very simple system with a very small load would then be feasible, this combination of a heat recovery unit and an air source heat pump. That then would be the key proposal in terms of then meeting those loads renewably. So of course one then looks at how we would do that, and clearly we've got a roofscape. At the moment there's 10 metres squared of air collector which is addressing hot water on that roof. If that was retained, a new 2010 upgrade, it would leave something like 45 square metres of roof surface in addition to the 10 square metres which could be solar photovoltaics on one side. Now of course the possibility exists, we've got glazed spaces in each side of the building, orientations change. We could actually make use, depending on orientation, of more than one side. But if we just stick to the idea of using one roof surface, that would give us 45 square metres of PV, in other words 15 square metres for each of the apartments on each side of the stairway. And that should yield enough energy to cope with the small space heating load of roughly, I would estimate, 800 kilowatt hours for the space heating, and enough left over to meet lighting and pumps and fans. So it's within the grasp of an upgrade. Of course, the issue might well be cost, but we're now entering a new phase of feed-in tariff and therefore the economics of such a roof with both solar thermal and solar electric, solar photovoltaic on the roof would make that feasible. The whole thing, of course, is predicated on a fairly significant financial upgrade, but one must bear in mind that provided one assumes that tenement flats, three-storey tenement flats, is a viable housing form, and I would suggest that given the evidence from right to buy in such accommodation, it still is a viable form, and provided that the capital investment is there to bring U values to that value, the passive house value, essentially, the whole thing is a reasonable proposition. Of course, this is a particular case study. Nevertheless, that type of approach could be used for other low-rise housing of this form. Other problems exist for high-rise, but I'll leave that for my colleague to discuss. Thank you.